Hi, Algebra 2, and welcome to a Friday E-Day. I wanted to walk through on video with you a couple of the concepts that will help you work through the set of problems I'm going to ask you to do today. So we're working on multiplying and dividing radicals. And in class this week, we talked a little bit about these concepts, the product property of radicals and the quotient property of radicals. And we're going to go ahead and put those to use today. So this is the second time through for a lot of you guys. And so I'm hopeful with some reps that this will start to clear up a little bit. So obviously you want to have your notebook handy, and you can write some notes down here that might help you during the assignment for later today. So I want to remind ourselves of these properties of radicals. And these are the same properties that apply to square roots. They also apply to any other root. So you see here nth root, so whatever number that is, a cube root or a fourth root or whatever. And so the product property says that if I take a square root, I can take that radicand, in this case the 16, and split it into two factors, and each one can get its own radical. So in this case, they're taking a cube root, and that's why they split this into 8 and 2, right? 8 is a cube root, or is a perfect cube. It's 2 times 2 times 2, right? So that's why they split it up this way. Obviously, 16, the square root of 16 is 4, so if they were taking a square root, it would not look like this. But if you remember back in class, this is kind of the way that we broke this one up. We took square root of 72, and we talked about splitting it into two factors. And eventually we said we were going to split it into square root of 36 and square root of 2. Why would we do that? Because I can simplify the square root of 36 to just 6. So square root of 72 is equal to 6 times the square root of 2. Likewise, I can take a quotient. I'm not allowed to leave a fraction underneath a radical, but the quotient property says I can take the numerator and denominator of the fraction, and each can have their own radical sign, and then I can use that to try and simplify. And so you might ask yourself, well, does this work the other way? And it turns out that yes, it does. So if I was asked to simplify something like square root 5 times square root 20, well, square root 5 is already simplified. Square root 20 I can break down into 2 times the square root of 5, but that's kind of messy. And it turns out that, yeah, I could show you how you could take those three pieces and make it work out nice and neat. But let's bypass that and recognize that by the product property, I can take 5 times 20, which is 100, and rewrite this as the square root of 100. So square root 5 times square root 20 equals square root of 100. Well, that I can simplify to 10. And if I had something like square root 8 times square root 9, which I can rewrite as the square root of 72 because 8 times 9 is 72. And we just did that example. And split that up into square root 36 times square root 2 and get 6 times the square root of 2. So this is a pretty valuable tool for helping to simplify radicals. And this second bullet point really shows you how it works in both directions. So one more thing I want to think about. Now that we know about roots with an index other than 2, cube roots and fourth roots and so forth, it's very important to know that the product property only applies when the roots have the same index. So I can't multiply the radicands of a square root times a cube root and think that that works, right? Mathematically, it's not possible. So let's look at an example. Which of these expressions cannot be simplified using the product property? And this is an example of what we just talked about. Here's a cube root and a square root. So I can't take 8 times 64 and then take some type of root of that, because look at this. This one's a cube root. This one's a square root. Which root am I supposed to take, right? That doesn't make any sense at all. I can still simplify that in other ways, but I can't multiply the 8 times the 64 and write it with one radical. So let's try one more for practice. So we're asked to simplify the expression square root 27 times square root of 5. Okay, so what is that going to look like? Well, the first thing I know is I can multiply these two things together and write them under one radical sign. So 27 times 5, 135. 20 times 5 is 100, 7 times 5 is 35, 135. Okay, so now I look at this and I say to myself, okay, I need to simplify this. I want to go ahead and split this up into two factors. And remember, one of them needs to be a perfect square. So what we found out in class is we're going to take our calculator and we're going to test the different perfect squares. So I'm going to take 135 divided by 4. Okay, it's a decimal. That's not going to work. So let's go 135 divided by the next perfect square, which is 9. Oh, 9 times 15. If you want, you can keep going and see if there's a bigger perfect square. If there was, then 15, this remaining factor, would have a perfect square factor. And I know it doesn't. It's only factors with 3 and 5. So I can actually stop now. So 9 times 15. So each of these gets its own radical. Square root of 9 is 3. Square root of 15 can stay as it is. So this exercise, square root of 27 times square root of 5, when we go to simplify that, comes out to be 3 times the square root of 15. Which was this option right here. Right. So I'm going to have you work through the rest of this quizzes as part of the assignment for today, but I wanted you to have a video with a couple of examples that will help you work through these problems. You can keep your notes by your side as you work through these.